Michael, and this is the last Log4J talk you'll ever need. So a bit about who I am and what do I do. I code, I teach, I hack. In other words, I spend most of my days on work and off bashing my head against the keyboard in the AppSec space, either to get code to work or to break other people's code. And in that concussive stupor, I also try to stand behind a podium, stage, whatever, and give insights on my experiences to everyone else. I must add the disclaimer, although I do have an employer currently, I do not speak for the corporate hive mind. I am just one of its many cogs. So, moving on to what we're talking about. On your left, you see one of the most popular logging libraries in Java, and on the right, you see your ticket to shells, and it's all about gaining a pocket full of shells. And take note of the CVE. Don't get it confused with any of the other ones, like for example, CVE 45046 or any of the others. They're nice, they're good, they're ways of exploiting systems, but the problem is they require effort. And that's not what we come here for Log4Shell. Log4Shell isn't about effort and insight, it's about getting arbitrary remote code execution anywhere and everywhere. And so, if you want to see the magical payload of what it takes to actually exploit Log4Shell, here it is. It is just the JNDI, LDAP, the location via the IP and the port, and the path to the exploit. And let's just take a deep dive and look in through it. Unlike most acronyms in IT, LDAP and JNDI are actually useful for explaining what they are. So LDAP, you'll see tutorials, classes, seminars, everywhere about that. The long and short of it is LDAP, Lightweight Directory Access Protocol, is just file operations over TCP/IP. That's just using internet web requests. How do you move files, delete files, create and edit files? So your basic file operations that you find in the desktop, how do you do it online? Do the same thing online. And the JNDI is just the Java name directory interface. And so why do you need to use JNDI? Why would anyone use JNDI in the first place? Is because of code reusability is the number one. So in each new project, you don't want to define basic things like shared libraries or database connections, configurations, templates, or for example, setting which logging server you want to use. You kind of want to have that code easily be reused throughout multiple projects, and the combination of these two, both LDAP and JNDI, helps facilitate that functionality. And so, just to dive deeper into the weeds, LDAP is the #1 provider for the JNDI SPI, which is just so you've got your Java application globally, and then the JNDI API and the naming manager. And one of the best ways to explain the use case of JNDI is DNS. So remember, in DNS, you don't memorize series of octets and just route to them manually through your browser. What you do instead is you use a human-friendly identifier like a host name, so it's defcon.org, google.com, etc. And then the service of DNS routes the human-friendly name to the machine-readable identifier. And it's the same thing with JNDI. You don't always know the exact path of classes and objects within the code base. So JNDI is really useful for designating that class path. And if you go through Java Oracle documentation for Java 7 and Java 8, the LDAP is just the #1 provider here. And so it's one of the most basic and most common use cases for doing something like that, reusing the same code and libraries throughout the projects. Now we go on to the kill chain. So and this is for Log4Shell specifically, you either spin up your own local LDAP server or you take over someone else's. Then you do anything within the context of the app that will cause it to log. This could include just modifying the body of a post request, but most often what you'll see in the wild is just modifying the header. A header that almost always gets logged is the user agent. And so when Log4J went out, if you wanted to walk around the internet and get random shells from everywhere, all you had to do was just change the user agent to a local LDAP server or one hosted remotely that you owned, and bam, you would get arbitrary connections. So the rest of the kill chain is that the app that just by including the payload, because the LDAP server is automatically trusted, the app will reach out to that server. The server will send a JNDI response, including the class, and then within that class, you can inject into the process and get remote code execution from there. Yeah, kill chain. Woo! So to facilitate this and make this a lot easier, set up a home lab in Minecraft. So it is built on Vagrant using Ubuntu, and of course one of the most popular Java applications out there. There is a number of benefits on why this particular architecture than others. Namely, I don't have to code Java. Getting things to I've spent like days and weeks of my life trying to get things to compile with Maven and Gradle, and I don't want to do that. I promise you I'm a developer. It's just for this particular project, I'm just going to use Ruby, and by Ruby I mean just enough Ruby to get some bash scripts in there. A few works cited. All of these exploit kits are available at GitHub. So the exploit kit we're going to use is the Fehan-CS JND exploit. That actually was taken down by who knows who. But one of the benefits of that is that we can find this sketchy exploit kit through the Wayback Machine and then use it within our VM. There are other exploit kits there are plenty of exploit kits for the Log4Shell vulnerability. Most of these are just, hey, they'll automate and streamline the process of standing up your own JNDI compatible LDAP server. Shout out to DA667 on Twitter. Mainly for the Minecraft version and the Java version, which is very important. Java, for this project, I'm using OpenJDK 1.8. 0 and making sure that the patch level is before 121, because from then onward, arbitrary class loading is disabled by default. So you not only have to have a vulnerable version, vulnerable Java application, you have to have the vulnerable Java runtime, vulnerable Log4J, and for this particular project, a vulnerable version of Minecraft, because as Mojang has discovered these things, it's gotten to the point where the basic date-time formatting that you normally were able to do within the chat, which is like $, curly bracket, date time, it's gotten to the point where players are no longer to execute basic things like that. So, moving on. Of course, with every sketchy exploit kit, use at your own risk. That's why we're doing it in the VM. And without further ado, let's get into the demo. All right, so hopping into the first command, you don't really need vagrant destroy attack F at the beginning. Really, all of this was really necessary is just the vagrant up and the vagrant reload. The vagrant up is to start the VM and the provisioners and get that started. The vagrant reload is just to, reboot the VM and get the virtual machine working. Vagrant destroy F is only needed if you need to blow it up and start again, as I had to do many, many times. So right now, we've got the vagrant up, just loading up the GUI. And all of this, of course, is because it's a vagrant box. It's listed in the vagrant file, and all the provisioners are included within that GitHub repo as well. The first part is what the GUI, which is just the VirtualBox provider popping up. When you do it at home yourself, just don't try to mess with it or do anything. The first thing that'll start is the TTY. I wanted to make this demo as simple as possible, so I avoided purposely made it simple enough to have the GUI start up before you do anything, because there's no sense in giving you a VM to just have to wrestle and fight with. I wasn't ultimately successful. We'll see an error message that I'm still working out at the end. The next part of that is just recording downloading the Minecraft assets and the exploit kit. As I was talking about before, the particular script that I was using was the Feyong-CS JNDI exploit. And of course, there's an elegant solution involving, cloning everything and all that. But since the repo was taken down, just curling the Wayback Archive was the best bet here. It does seem the VM does appear to just, stall and do nothing for a little while. The reason for that is because I just am tired of blowing up the terminal with arbitrary output. Like the apt-get and installs are already bad enough. So what I did is just made this part quiet and silent. If you have some networking issues, of course this all crashes and fades away, but for the most part, this is just getting all of the assets, installing not only the exploit kit but Java, making sure that all the environment variables are set, and these things are batched into stages for each of the revisioners. Onward. And then, shortly after all of the Minecraft assets and the exploit kits are downloaded, what we'll do is we'll just wait for the rest of it to install, then do a full reboot. One of the main provisioners that will always run is the serve.sh bash script. All it does is set up two screens. One will have the malicious LDAP server set up, and the other one is going to have the Minecraft server set up. So there is going to be a big error, and I spent days on this. And for some reason, just graphics and drivers issues just would got in the way of this build. But the server started up, everything else is fine. The EULA acceptance script is pretty easy to get around, and you can dive all the details to when you see it in the repo. For right now, we're just booting up the VM, and then now that we've got a GUI, just log in with the Vagrant default credentials. and getting started. Another part of the setup is just now that migration happens, have to have a Minecraft account explicitly set aside for this. Yeah, just jump cut to avoid throwing the password out there. Let's go. And of course, just so many loading screens. The Java version, which has not showed, is OpenJDK 1.8.0 with a patch level before 1.2.1. And for this particular installation of Minecraft, I really want to target 1.12.2. It's very popular. It's obviously legacy. And one of the reasons is because of the modding community. So you're just going to set play and agree. Now, the one error that just was a complete showstopper, I don't know why, because I'm thinking it's the distro or whatever, and we can get to the other, is just an array index out of bounds, which I included in the repo. I promise you I got this working in a previous YouTube video, and we'll just pull up the screenshots for those and discuss that instead. But yeah, after this loads up, it's just array index out of bounds error. For some reason, it just cannot find the primary display. So graphics and display driver issues is just par for the course for pretty much any Linux distribution. So yeah, it's just graphics drivers issues, and by the time I got this recording in, I did not have this issue resolved. I am hoping by the time present this in person that the issue is resolved. Yeah, par for Linux driver issues, graphics driver issues. So alternative solutions would probably run this on Jammy 64 instead of Bionic, which is what I did in YouTube. And if you hold up a second, the error message should pop up ever so slightly. It's null pointer exception, and for some reason it's this particular install and configuration can't find OpenGL for some reason, even though like my display and everything works fine. I've covered up but that quick pop-up for a second was the null pointer exception, and the full stack trace, of course, was available in GitHub. The first screenshot is the actual payload in the context of Minecraft. This is taken obviously from the YouTube video that I did for the project when I recorded in December, and the IP address is just the network configuration for this particular virtual machine. The base 64 encoded payload is just the ls command, and you see on the right is the stack trace within the game, and this is not the stack trace, the server logs, and you see like that class name foo, and that's the JNDI output of uploading the class name. You can look into the exploit kit, and you can use it for reverse shell, other commands, base 64 encoded and otherwise, and that's it. So let's talk about the impact here. I mean, after all, Minecraft isn't really a good scenario for simulating the enterprise impact of Log4Shell. After all, it is an application based on a popular cross-platform framework, hosted publicly, with legacy dependencies, a user base of hundreds, if not thousands, of users at one time, and actually is resistant to updates and changes because it has a consistent revenue stream. So yeah, Minecraft is of course never a good example. So what about remediation? So how about fixing this? It's easy to say, just patch your systems. That's the number one key thing. Use if the logging version of Log4J is configurable, go into the configuration settings and do the patch. Otherwise, most of the Apache projects have already updated. It's no longer considered a 0-day. However, some arbitrary application that's built on the Apache services may not be patched, in which case this is one of those things like arbitrary remote code execution being exploited in the wild. This is where as security practitioners, professionals, you could say, just change your technology stack. And that is the best answer and the best way we can go forward with that. So there have been other ways of trying to remediate using regex and all of that. Just really, so seriously, patch to later past 1.2.18 for Log4J and move on. So the reason why this talk is called the last Log4J talk you never need rather than the last Log4Shell is because it's really easy when a huge vulnerability comes from a particular library that the library itself has no functionality and utility. It's all about the number one global vulnerability. That's sort of part of the risk with free and open source software. However, this is just yet one of those cases where one simple little library forms the backbone of digital infrastructure globally and worldwide. And you may think, like, as if you're doing penetration tests and offensive security, you'll find things like for example, jQuery and others, where it seems like instantaneous. It blows up, and these libraries are vulnerable. It blows up your scan logs and servers because there's always a patch coming, always a security patch coming. That's not necessarily a vulnerability, that it is actually part of the feature. And so it's not just part of a remediation process. Part of what makes good application security work in the real world is just having a community, development, maintaining community that is in line and coupled with the security community, so that when something comes up, the security patches are rolled into the release pipeline. And the Log4j developers actually did their best. Before it was just like disabling and all of that, but as the entire world had scrutiny on this one library for a period of a few weeks, removing the function out, it eventually got the pushback to remove the arbitrary JNDI lookup functionality altogether, which is I know it seems obvious, it seems insane. Why would you trust arbitrary lookups, remember, it was a feature of the library pretty much until November. So part of going forward, part of the lessons learned is for every free and open source, for every library package, find part of it is not only just its feature set, but also looking into the community. Does it release security patches often? Is it well maintained and well funded? Is this something that you want to be able to integrate within your own technology stack? And of course, these links, I'm active pretty much in way too many places. It's free OSINT, so feel free to harass me on any of these platforms. And my favorite part of the talk, the actually portion. So if you have questions about the setup, what I did, and also mistakes that I made, feel free